Class on Demand, and it's time for us to look at multiple spanning tree protocol, often referred to by its IEEE acronym. Acronym's probably the wrong word there. Known by its IEEE abbreviation. I don't know what the correct word is. Someone needs to mail me the correct term. But anyways, the IEEE refers to it as 802.1S. That's multiple spanning tree protocol. And a lot of confusion about this, and I think one of the reasons is Cisco kind of brought some of the confusion on themselves. In their initial implementation of the Catalyst switches when it comes to the multiple spanning tree and rapid spanning tree, here's what they did. They gave you two choices initially. You could run the default per VLAN spanning tree plus, or you could do multiple spanning tree. And when you do multiple spanning tree, and keep this in mind, folks, when you do multiple spanning tree, you get rapid spanning tree by default. So enabling multiple spanning tree in your environment, that gives you automatically the rapid spanning tree protocol behavior we spoke of last session. Now, you know that in today's environment, you can actually choose to just run rapid spanning tree, and that's what's utilizing that mode we showed you of rapid PVST+. When we do multiple spanning tree protocol, we're really doing, this is an interesting observation, an open standards type approach of PVST+, but with a great benefit. You see, we're going to be able to define exactly how many PVST+ instances, if you will, we want. Whoa, this is going to be a dramatic shift in paradigms here. We can create, this is I think the best way to say it, we can create as many spanning tree topologies as we need. Now, the underlying process is our rapid spanning tree protocol process, and nothing's changed there at all. So really what's changing here is how many different spanning tree topologies we're going to define in our network. One of the things I think students struggle with a bit when it comes to multiple spanning tree protocol is what's wrong with per VLAN spanning tree plus? After all, that's a really fancy name, and Cisco invented it. What's the issue with it? Well, I think the issue with it is you're forced into a different, quote-unquote, different topology for each and every one of your VLANs. Now, we know by default the topology is the same for each of the VLANs, but notice it is a unique instance of spanning tree protocol. That means the BPDU overhead and all that stuff is still going to be incorporated. I mean, we still have to deal with the overhead of a unique instance, and unique probably isn't the right word, right? But at least a independent, that's a bad word too. Boy, it's tough to describe, but you get the sense. Every single one of your VLANs has its own spanning tree. And that might be absolute overkill from an overhead perspective. What's the problem with the old approach of common or mono spanning tree? Well, mono spanning tree, that sounds like something you'd catch in your high school that would make you very ill. But the issue with the common spanning tree is the fact that it's simply too basic. Having one topology for all of your VLANs doesn't do well when it comes to your utilization of ports and your bandwidth, and doesn't offer you any load balancing whatsoever. Something that you're going to be thrilled about with multiple spanning tree protocol is, like rapid spanning tree protocol, it's totally backwards compatible with the earlier PVST+ and CST technologies. The multiple spanning tree configuration involves your configuration of what we call a region. The region is going to be made up of all your switches sharing three pieces of information: a region name, a region revision number, and the VLAN mappings. What VLANs go with what particular multiple spanning tree protocol instance. And that's the official word from the RFCs. It's an instance of spanning tree. The revision number, this is the thing that confuses everyone. Just think of it as like a version number. Like we have Microsoft Windows version 7. That's exactly what you want to think of here. It's a number that you're applying to all of the devices, and it is going to allow you to, as you kind of redesign your infrastructure, you can just increment your own revision number. I think the thing that's so confusing for folks on this is they get it confused with the configuration revision number in VTP, and they think that's how this works. No, nothing like that. Just think of it this way. I think this is the best way to do it. Your region name, just think of it as a two-part name. You got a name and a number that actually make up the name of the region. I think that should help you. Let's take a look at the configuration. I won't bother to bore you with the command line, pasting this into all 4 devices. Let's just look at the configuration we would make and we would paste in to all of our devices. The first thing that you need to do, and it's amazing, but I often see this left out of Cisco's curriculums and Cisco's documentation. I mean, it's amazing. They forget to tell you this, and it is obviously critical. You have to do the spanning tree mode command, and you have to set the MSTP mode. And obviously, if you forget that, you're in big trouble. So let's not forget that critical first step. Once you've got the mode set over to the MSTP, you'll want to go ahead and enter MSTP configuration mode with the command spanning tree MST configuration. Then, once you're in that correct mode, you can give your region its name, its revision number, and then map the VLANs to the instances that you are creating. Remember, you'll get a spanning tree topology per instance. So in my example here, we're going to have 2 instances of spanning tree in our environment. One for VLANs 10 to 2002, and the other for VLANs 2003 to 300. If you want to go ahead and manipulate one of the VLANs, the groupings of VLANs, here you can see I'm setting the current device we're on to be the primary root for all of the VLANs covered by instance 2. So this configuration, minus that last line, is what you would copy and paste into all of your switches. Well, what's next on our agenda here in the Advanced Technologies Class on Demand course? Well, let me check. Why don't I? Oh, what's next? We're going to kind of remove ourselves for a moment from the topologies and technologies of spanning tree protocol, and we're going to move to look at a really nifty feature on our Catalyst switches called SPAN and RSPAN.